Stop scrolling. Reuters reported today, February 4th, 2026, that SpaceX xAI are tied to a vision that sounds like science fiction. AI data centers in space, not a new chatbot. A push to scale AI compute beyond Earth. One-sentence summary. Reuters says SpaceX sought FCC permission for up to 1 million solar-powered satellites designed as an orbital data center system, linked by optical connections, with experts warning it could take years, even up to a decade, to become viable at scale. 3 verified facts, 3 unknowns, fast. Verified. Reuters reports the FCC filing describes an orbital data center system using solar power and optical links. Verified. Reuters reports the scale mentioned is up to 1 million satellites. Verified. Reuters reports hurdles include radiation, debris, heat management in vacuum, latency, and economics. Unknown. The timeline, the real cost per unit of compute versus Earth data centers, and who controls access if it works. Now the twist. If this sounds too wild, remember, every infrastructure shift starts as an idea that feels impossible, then quietly becomes normal. When AI gets slower, pricier, or capped, that is rarely a model problem. It is an infrastructure problem. And this story is about the next layer of AI infrastructure. Part 1. The hidden bottleneck that makes AI feel limited. Overnight, every AI answer triggers a physical chain. Chips run in a data center. Electricity flows in. Heat pours out. Results come back so fast, it feels like magic. But the rule behind the magic is simple. AI turns electricity into intelligence. Here is the part nobody notices until it hits their wallet. AI demand does not rise gently. It spikes. A new feature drops, creators rush it, businesses integrate it, and suddenly the same system serves millions more requests per hour. That is when you feel the shift. Try again later. You've hit your limit. Upgrade for more. And people say the model got worse, but often the model is fine. Capacity is what changed. Now, zoom out. Earth-based scaling runs into hard limits: power, cooling, land, and time. Power grids are finite. Permits are slow. Cooling is expensive and politically sensitive. So expansion becomes a negotiation with reality, not just an engineering plan. Make it personal. Creators feel scarcity as render queues and output limits. Businesses feel it as higher tiers and usage caps. Students feel it when tutoring tools get throttled. And everyday users feel it when free features turn into rationed features. But here's the scary part. Scarcity concentrates power. The companies with the most compute can set prices, decide who gets priority, and ship upgrades faster. That means the next AI leap may be decided less by a breakthrough paper and more by infrastructure decisions most people never see. Now connect the dots that make this headline explode. SpaceX operates at scale: manufacturing, repeated launches, and constellations. xAI competes in a market where compute is oxygen. So when Reuters describes AI data centers in space, the subtext is blunt. The compute bottleneck is so severe that serious players are exploring beyond Earth. And one more twist. When infrastructure becomes the moat, everything else follows: pricing, access, and even who gets to compete. Now let's unpack what servers in the sky actually means. Part 2. 1 million satellites is not a prototype. It's a planet-scale signal. Numbers first, because they change the vibe. Reuters says SpaceX sought FCC permission for up to 1 million solar-powered satellites designed as an orbital data center system. That is not a weekend experiment. That is a planet-scale signal of ambition, at least on paper. So what is the concept in plain English? A normal data center is a factory that turns electricity into compute. The space version breaks that factory into many smaller units, satellites that harvest sunlight, run computing hardware, and connect through a network. Reuters mentions optical links, which hints at a mesh where units can route data between each other before sending results back down. But wait, here is the trade-off nobody gets for free. A distributed orbital data center is not automatically cheaper. Launch costs, replacement cycles, shielding, and thermal systems all add up. So this is not space is free. This is space might unlock different constraints. Now watch how this flips the AI business model. If a company can add compute capacity without relying on local grids and local permits in the same way, it can scale faster when demand spikes. And in AI, scaling faster often means winning the next cycle. Advocates point to energy and heat. Reuters quotes Musk arguing that, long-term, space-based AI compute is the only way to scale, pointing to the vast energy of the sun. But here's the catch. Harvesting energy is not the same as delivering cheap compute. On heat, Reuters notes advocates say heat can be dissipated by radiating it away. Here is where it gets messy. In orbit, there is no air cooling, so heat management becomes a design constraint. Radiators and safe power density choices decide what is possible. More radiators can mean more mass. More mass can mean more cost. Now the contrast that keeps you locked in. 3 reasons it could be genius: energy leverage, constellation operations experience, and a networked architecture suggested by optical links. 3 reasons it could fail: economics, radiation reliability, and debris governance at scale. Latency matters too, because some workloads need instant response. Here's a practical reality. If this ever works, it likely starts hybrid. Some tasks stay on Earth, while certain workloads that tolerate delay run elsewhere. That's an inference, not a Reuters-confirmed plan. And now the line that should make you lean forward. The biggest risk might not be technical. It might be who controls access if this becomes real, and who gets prioritized when demand spikes. Hold that thought. We are going there in Part 4. Part 3. The first place you'll feel this is not space. It's your subscription, your queue, and your time. If this vision ever becomes practical, you will not experience it as space tech. You will experience it as less friction, less waiting, less gating, more consistency. And for creators, consistency is revenue. Scene 1. Creator Mode. You are generating a short AI video for tonight's upload. You click Generate. The progress bar crawls, not because the model is broken, but because thousands of people are in line. You refresh, you wait, you compromise, or you pay more to skip the line. That is compute scarcity made visible. Scene 2. Small Business Mode. A shop owner uses AI to summarize tickets, draft replies, and build weekly reports. They love the results. Then pricing hits, caps, tiers, and paywalls. Here is the twist. Many businesses do not quit because AI is bad. They quit because AI is expensive at scale. Scene 3. Student Mode. AI tutoring, translation, and research support scale with compute. When platforms are constrained, features get throttled. When capacity grows, access broadens. Now the direct U lens, fast. If you're a creator, this is about render queues and tool limits. If you're a worker, this is about productivity tools being affordable, not rationed. If you're a student, this is about learning support that doesn't vanish behind a cap. If you're a business owner, this is about AI being a utility, not a luxury add-on. If you're a normal user, this is about whether AI feels reliable or unpredictable. But wait, here's the twist that changes the mood. Expanded access and centralized control can rise together. A system that increases capacity can also decide who gets it first. In a minute, I'll tell you the single reason this idea could change AI pricing faster than any new model. Because it's not the rockets, it's what rockets enable. One more clarity beat. The keywords people are searching right now are AI data centers in space, space-based AI compute, and orbital data center. Because people can feel the bottleneck, even if they can't name it. Part 4. The real story is control, regulation, and the new AI moat. Let's re-hit the detail that makes this real. Reuters says SpaceX sought FCC permission for up to 1 million solar-powered satellites in an orbital data center system. That is not a guarantee it happens. It is a signal of scale, ambition, and direction. Now here's the payoff. This idea could change AI pricing faster than any new model because compute is the moat. When compute supply expands, competition gets brutal. Brutal competition pressures prices, and prices determine who can adopt AI at scale. But here's the scary part. The bottleneck becomes a lever. Whoever controls compute can influence pricing, availability, and rollout speed. That reshapes competition timelines because the company that can train, iterate, and deploy faster can dominate product cycles before rivals catch up. Now, the expert reality check. Reuters highlights the hurdles: radiation, debris, heat management in vacuum, latency, and economics. With experts warning it could take years, even up to a decade, to become viable at scale. This is where regulation enters the chat. If compute becomes strategic infrastructure, it attracts oversight. A planet-scale orbital system would trigger questions about safety rules, debris mitigation, cybersecurity, and transparency. Who audits it? Who enforces standards? What happens if critical services rely on it? Winner versus loser snapshot, quick and honest. Winners: whoever controls compute supply, launch cadence, and routing. Winners: companies that can secure affordable AI capacity when everyone else is capped. Losers: smaller AI startups if access gets gated. Losers: consumers if scarcity keeps prices high and features locked behind tiers. Another twist: even if space data centers never become dominant, the chase accelerates innovation on Earth. Efficient chips, better thermal designs, stronger networking, and new energy investment. But if space-based AI compute becomes viable, the control question becomes unavoidable. And that's why this story is not only about engineering, it is about who gets to build the next layer of the internet. Part 5. The next 12 months, the next 5 years, and the sentence you will remember. Let's predict without pretending it's fact. The most likely next step is not a full orbital data center. It's proof points, prototype payloads, testing power, thermal control, and communications. That's how moonshots turn into schedules. My clear prediction: the first milestones will be narrow and practical. Can a compute node run consistently? Can it manage heat safely? Can it move data efficiently enough to matter? If those answers start turning positive, the entire industry reacts fast. 3 future paths. Path 1. Niche success. Specialized use cases where the economics justify complexity. Path 2. Hybrid scaling. Earth data centers stay the backbone. Orbital compute becomes supplemental for workloads that tolerate latency. Path 3. Disruptive shift. Costs and reliability improve enough that an orbital data center becomes a meaningful share of AI infrastructure. But here is the line people do not want to sit with. If AI becomes as foundational as electricity, compute becomes a strategic resource. Strategic resources attract competition and power struggles. So the real question is not only can we build AI data centers in space, it is who controls them, who benefits, and who gets cut off when demand spikes. So what is the takeaway from Reuters today? Not that servers move to space tomorrow. The takeaway is that the compute bottleneck is so serious that serious players are exploring beyond Earth. Now the sentence you should remember. The next AI superpower might not be a country. It might be a launch schedule. If you want daily AI updates with context, subscribe. And comment one word: genius or dangerous.